In this video, we are going to learn about 8th grade exponents. We were first introduced to exponents back in 6th grade, and we learned that when something is in exponent form, it is where there is a base. The big number is the base, and there's a little number, that's the power. So if we had a number such as 2 raised to the third power, this is the same thing as 2 times 2 times 2. So we have to know how to convert something that's where it's 2 times 2 times 2 and convert it into 2 to the third power. Or if it's 2 to the third power, we have to understand that's what the operation is. And if we were to evaluate it, this would be the same thing as 8. So we can write numbers in exponent form, we can evaluate, and we probably worked with powers of 10 or base 10. So 10 to the fourth power. Well, this is 10 times 10 times 10 times 10. And here, one easy way to do this is we can just write the number of zeros. 1, 1, 2, 3, 4. So 10 to the fourth power is the same thing as 10,000. And then from there, we can have a base that's a decimal, or we could have a base that's a fraction. So for example, if we have 0.2 to the third power, back in 6th grade, we learned about how to multiply decimals. So it's important to remember this is not 0.8, but instead it's 0.2 times 0.2 times 0.2. 2 times 2 times 2 is 8. But because there are 3 digits to the right of the decimal point, it is going to be 0.008. You can also do this with fractions. 1/5 to the third power. Well, that's 1 over 5 times 1 over 5 times 1 over 5, and that's going to equal to 1 over 125. So then from there, maybe in 7th grade, we learn just a little bit more. And then in 8th grade, then perhaps that we will start getting introduced to working with negative exponents. So in this case, what if we had a number 3 to the negative 2 power? So just for now, we're just going to memorize that when we have a base or a number to a negative power, this is the same thing as 1 over 3 to the second power. So we put 1 with the same base, but with a positive power. From there, we can evaluate negative exponents. Well, that is the same thing as 1 over 9. We can evaluate powers with a negative base or with 0 exponents. Here we might have negative 2 to the second power. And you might think that this is positive 4 because it's negative 2 times negative 2. But because there's no parentheses around the negative, this is actually the same thing as negative 1 times 2 to the second power. So therefore this would be negative 4. It would be positive 4 if it was negative 2 with the parentheses with the second power, because this is the same thing as negative 2 times negative 2, and a negative times a negative is positive 4. The rule applies in a similar way when something is to the 0 power. So the fundamental rule is any number to the 0 power is 1. But if you had negative 2 to the 0 without a parentheses, well, technically speaking, this is the same thing as negative 1 times 2 to the 0, and that's why it's going to be negative 1 versus negative 2 to the 0, where there is a parentheses, is going to be positive 1. So one of the most important things about working with exponents is identifying the base. If you know what the base is and you know how the power applies to that base, then really it's just repeated multiplication and remembering that any number to the 0 power is 1. So even if it was 0.2 to the 0 power, that's 1. 1/5 to the 0 power, again, is 1. Any number to the 0 is 1. Then from there, we can learn about multiplying powers with integer basis. So what if we had 2 to the second times 2 to the third? Well, you might be tempted to say that this is the same thing as 4 times 8, which indeed is 32. But what if it was 2 to the 22nd times 2 to the 33rd? Well, we wouldn't want to evaluate 2 to the 22nd power. And in this case, it's important to understand that, and I'm going to take the simple example first, 2 to the second power is the same thing as 2 times 2. 2 to the third power is 2 times 2 times 2. And we could understand that this is the same thing as 2 to the fifth power. So when you have the same base, you could just add the powers. This is the same thing as 2 to the 2 plus 3. So therefore, in this case, without having to evaluate, this is the same thing as 2 to the 55. So yes, we can convert if we have to, but at the same time, if we could just work with what's given to us, then it's usually easier to get to the answer. We can also divide powers. So if we had 2 to the fifth over 2 to the second, in this case, what you do is that when you have the same base and you are dividing, you subtract the powers. So this is the same thing as 2 to the 5 minus 2, which equals 2 to the third. As you're learning this material, I think it's also important to, yes, there's a lot of memorization in school, but at the same time, it's also a good idea to understand why this occurs. In this case, it's 2 times 2 times 2 times 2 times 2 over 2 times 2. And if you notice, these 2's are canceling out to be 1, and that's why you are subtracting the powers. Now we're going to go through the power rule. What if we had 2 to the second power to the third? When you have a power to a power, what you do is you multiply the powers. This is the same thing as 2 to the 2 times 3, which equals 2 to the 6. Again, based on the rule that we just learned about where we add the powers when you are multiplying with the same base, this is the same thing as 2 to the second times 2 to the second times 2 to the second. And this indeed is going to be 2 to the 2 plus 2 plus 2, which is 2 to the 6. And from there, if we understand how to work with integer bases and how to multiply or divide or take a power to a power, then the rules for variables is the same. So we can have x to the second times x to the third. Well, that's x to the 2 plus 3, which is x to the fifth. If we have x to the fifth over x to the second, well, this is the same thing as x to the 5 minus 2, which equals x to the third. X to the second to the third, this is x to the 2 times 3, which is x to the 6. X to the negative 2, well, this is 1 over x squared. X to the 0, well, any number to the 0 is 1. Now, as you get into more advanced math, there will be some cases where you will have to give it a little bit more thought, but for now, x to the 0, any number to the 0 is 1. And from that kind of basic knowledge of exponents, then really you can do a lot of different problems, whether it's simplifying or evaluating or working with exponents, just based on knowing these fundamental rules. So we're going to stop it here, and then we're going to go into more challenging problems in another video.